In this video, we are going to attempt to demonstrate the triangle inequality. That is to say, we're trying to show that the sum of any two side lengths of a triangle will be larger than the third side. In order to show this, we're actually going to use a proof or a theorem that isn't covered here but is covered later. But we're going to demonstrate it non-rigorously for right now. Okay? So, in order to demonstrate the triangle inequality, we're going to make use of the theorem that says basically when you have a triangle that the angle corresponds somehow to the opposite side. Okay? Notice that this angle, being very small, corresponds to a very small side. This angle, being much larger, corresponds to a large side. This one being about the same size, not completely sure if it's congruent, but it's very close. Corresponds to a side that is also very similar in length. Okay? Well, how else can we perhaps view this? Okay? Let's take another triangle really quickly here. And just examine how this angle plays a role in determining the sides. Okay? So if we extend this angle just a little bit, if we make this angle larger, and we were to draw that triangle, what happens to the opposite side? Well, as you can see, it is much larger than the original opposite side. Likewise, if we shorten it up, okay, say against that point, the new side length is much smaller than, again, the original. So, larger angles correspond to larger opposite sides when we keep, say, this other side fixed. Okay? If we change this size, then everything goes to a different place. The other requirement is that we know that this angle is kept constant from here. Okay? This is a proof, again, that's shown more in detail in Chapter 4. But basically, the two takeaways from this are that larger angles, from this guy, larger angles correspond to larger side lengths, and from this one is that given a particular known side, a larger angle sweeps out to a larger opposite side for the same kind of triangle where you know one angle, one side, and the other angle. So, moving on to the actual proof of the triangle inequality now. We start with a triangle ABC. Okay? So a triangle we'll just create rather quickly here with point A, B, and C. Okay? So in this case, I'm just going to draw that. Connect the dots. Okay. Alright, so for triangle ABC, we are actually going to use our compass now. Okay. Have the tip at C and the pencil at B, and sweep out the circle CB. Okay. Now that that's done, we're actually going to continue the segment AC out to the circle, to where it intersects. We're going to call that point D. Okay? So, since C is the center of a circle, CD is a radius, CB is a radius, they must be congruent. Okay? Let's also draw the chord BD. So, what things can we pull from this? First, AC plus CB, well, if CB is the same as CD, this entire length up here is the sum of two sides of the triangle. Okay? Now, when we do this, we can look and we can say, okay, we've got this angle here, and this angle here. Okay. Those two must be equal and opposite by virtue of them being an isosceles triangle. Okay. Two radii are congruent. Okay? But then we notice that this guy is a little bigger. Okay? So since this side, this overall, the angle ABD is larger than the angle ADB, then we know that this side, because it's opposite a larger angle, must be larger than this side, which is opposite the smaller angle. And that is how we demonstrate that the sum of any two side lengths of a triangle will be larger than the third side. Now, notice this is general, which means that we could have done it for any pairs of side. AB plus BC would be larger, in this case, very obvious, than the third side, AC.